All right, this is the Geometry Unit 2 Part 2 review. We've got all these different properties in a definition, and we're trying to match them. All right, so we've got if angle A is congruent to angle B, then the measure of angle A is the measure of angle equal to the measure of angle B. If you go from congruent statement to an equation or equation to a congruent statement, we travel through the definition of congruence to do that. And so we see choice C, definition of congruence. Number 2, if y equals 5, then 5 equals y. If you switch sides on an equation, then that's the symmetric property that allows you to do that. So choice H. If segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. And so we have the right-hand side of one congruent statement matching up with the left-hand side of the other. And so we can put them together and say that segment A is congruent to segment AB is congruent to segment EF, which we have here. That's called the transitive property. AB, that's the distance from A to B, is equal to the distance from A to B. And that is the reflexive property, which allows something to be congruent or equal to itself. All right, we've got a few more of these. X divided by 7 equals 3, then x equals 21. What we would have to do here is multiply both sides by 7, and it's the multiplication property of equality that allows us to do that. If a plus b equals c, then a equals c minus b. To go from the first statement of the hypothesis to the conclusion, we would have to subtract b from each side, and so that's the subtraction property of equality that allows us to do that. So choice F. If b is between a and c, then ab plus bc equals ac. Segment addition postulate allows you to add the measures of segments that are adjacent and collinear. And then the property that allows you to get rid of the parentheses over either subtraction or multiplication, or to get rid of the parentheses when you multiply across either addition or subtraction, is the distributive property. Determine the point of intersection of lines M and N. So line M right here, line N right here, they intersect at point B. If the measure of A equals 5x minus 12, measure of B is 2x plus 18, A and C are complementary and B and C are complementary, find x. Alright, so complementary means they add up to 90. Alright, so measure of A plus measure of C is 90. Measure of B plus measure of C is 90. And so what this means is that measure of A and the measure of B must be equal. That's the complement theorem. So the measure of A equals the measure of angle A, is equal to the measure of angle B. Substitute in, since A is equal to 5x minus 12 and B is equal to 2x plus 18. We can substitute in, and then we'll get the variables on one side. Subtract 2x from each side. The subtraction property of equality allows us to do that. And then add 12 to each side, and we get 30. So 3x equals 30. Divide by 3, and we get x equal to 10. Goal here was to find x, so we're done. If we wanted to plug it back in, we could find the measure of either angle A or angle B, or even angle C. Which best describes the statement? 3 points determine a plane. Well, sometimes 3 points determine a plane, but you have to think through what kind of points are these. If they are collinear, then they do not determine a specific plane. If they are non-collinear, then they do. So this is sometimes true. 3 points determine a plane. Sometimes 3 points will determine a specific plane. Sometimes it won't. So if they are collinear, they do not determine a plane. If they are non-collinear, they do determine a plane. So this is sometimes true. Which best describes the statement? Vertical angles are congruent. Vertical angles are always congruent. Remember, vertical angles are opposite angles formed by intersecting lines. So these two angles would be vertical angles, they would be congruent. These two would be vertical and they would be congruent. That is always true. If you have 3 collinear points, then we can say that AQ plus QD equals AD. That's true because of the segment addition postulate. Notice that Q is shared in both of these segments, so Q must be the one in the middle. You can also tell that A and D must be the endpoints because they're the longer segment. AD over here. And so Q must be somewhere in between there. It doesn't matter where you locate it. And so this distance from A to Q and then the distance from Q to D will total for the distance from A to D. So which point is between? Q. It's between the other two. Find the value of each variable. Okay. Vertical angles are congruent as we stated earlier. So x plus 30 equals 58, subtract 30, and we have x equal to 28. It's one of our variables. And then this angle 58 and this other angle y minus 7 will have to be supplementary since they are a linear pair. So we can write y minus 7 plus 58 has to equal 180. You can combine like terms and you'll get 51. And then to get rid of plus 51, subtract 51 from each side. And so we found the value of each variable. That's all we need to do. Sometimes you'll have to plug them back in. All right, if angle ABD is 63, so angle ABD, this angle, 63 degrees, find the measure of DBC. Well, you'll notice the right angle symbol there. That indicates that they are complementary. They add up to 90. And so you can subtract the 63 from 90. And so you'll see 27 degrees for the measure of DBC. X is 3 times the measure of 2. So if I let X to represent measure of angle 2, then 1 would be represented by 3 times that, 3x. Those are linear pairs, so they are supplementary. That's the supplements theorem that says that. 3x plus x must equal 180. So we get 4x equals 180. To get rid of multiplying by 4, divide by 4. And you get 45. So this one's 45. Our goal is to find the measure of angle 1. So you could either do 3 times 45, and you get 135, Or you could use the fact that 1 and 2 are supplementary, so you could do 180 minus 45. That also gets you to 135. All right, 4 and 5 are complementary. Because of vertical angles, we can say that since this right angle is there, the other vertical angle with it is 90. So 4 and 5 have to add up to 90. So we can write 3x plus 5 plus 5x minus 3 has to equal 90. Combine like terms, 3x plus 5x is 8x. 5 plus negative 3 is 2. Two-step equation from here, subtract 2. Get 8x equals 88, and then divide by 8. X equals 11. Our goal is to find the measure of each numbered angle. So let's plug this back in. If I go to the measure of angle 4, I know that that's equal to 3 times 11 plus 5. Multiply 33 plus 5, 38. You can either take that 11, plug it in right here, and help to allow you to find the measure of angle 5, or you can do 90 minus 38, because they're complementary. And so you'll get 52 degrees. So we found 4, 5, and 3 is a linear pair with the right angle. So it must also be a right angle. So the measure of angle 3 is 90 degrees. So we found the measure of each numbered angle. Yeah, pay attention to your directions there. It's easy to see that x is 11 and stop. So make sure that you're doing all that it's asking you to do. The value of x and the measure of each numbered angle. Complete the proof. All right, if yz is equal to 3xy, then zx would have to equal 4xy. All right, well, we can split up zx into xy plus yz because of the segment addition postulate. It allows you to add the measures of any segments that are collinear and adjacent. Segment addition postulate. And then if we substitute in, we'll have zx equals, instead of the zy, we can write 3xy. So we have xy plus 3xy. That's substitution property. And then when we do our calculation, 1xy plus 3xy is 4xy. That's the substitution property that allows us to replace something with what it's equal to. All right, here to get rid of plus 9, we'll subtract 9. Subtraction property of equality allows us to subtract the 9 from each side. And then our final step would be to divide both sides by 4, and you see a result of g equals 5. If you want to show that, you can do it right like this. This is one of those where sometimes you'll see it written as 2 separate steps. You'll see subtracting 9 from each side, and we'll just write it out, and then the next step we would substitute in with the value, and then we would divide both sides by 4. We'd show it, like write it out, and then do the calculation on the following step, in which case we say substitution property. So I'm fine with either 2 steps or 1 step for each of those. All right, we have two intersecting lines. They intersect at the point X. We have the measure of angle WXV. So this angle, we have an expression for that, and we have an expression for ZXY. Now those are vertical angles, and vertical angles are congruent. So we can say angle WXV is congruent to angle ZXY. And you can say vertical angles theorem, if you remember that, or you can say vertical angles are congruent. Anytime you have vertical angles, they're congruent. Since they're congruent, their measures are equal, so we can say the measure of angle WXV is equal to the measure of angle ZXY. And that is just a definition of congruent angles. We're going from a congruent statement to an equation. Since their measures are equal, we can, and we have expressions for those measures, we can say 4s minus 12 has to equal 2s plus 18. That's substitution property that allows us to do that. We've got variables on both sides. Let's get those variables together by subtracting 2s from each side. And so we'd have 2s minus 12 equals 18. It was subtraction property of equality that allows us to subtract the same number from each side, or same expression. All right, a couple more steps. Let's see, add 12 to each side. And so we get 2s equals 30. Addition property of equality allows us to add the same number to each side. And then to get rid of the multiplying by 2, we'll divide by 2, and finally we will get to our proof statement, which says s equals 15. And so it's the division property of equality that allows us to add the same number to each side. If you've enjoyed this video, click subscribe. Until next time.